To continue with these ideas, we're going to use this graph. First of all, horizontally real axis and vertically imaginary axis. And we have vertical and horizontal grids so we can plot ordered pairs, but we also have circles for when we begin to look at rotation, the measure of the angle. I've got a point here. It is at 4, 4. This point does correspond to a complex number. The horizontal part is the real part, 4, and the imaginary part is also a positive 4. So it is the complex number 4 plus 4i. The horizontal is our first term. The vertical is the coefficient of our second term, the imaginary term. Now, to begin converting this number into its trigonometric form, we are interested in what is the angle, the rotation, if we think back to our standard position here on the horizontal axis, and rotating some amount until we hit the point 4 plus 4i, 4, 4. This is the angle that's going to represent this complex number. We will also need to know what is this radius, how far away from the origin do we go. The angle measure we should spot right away. It is this perfect 45-degree angle. It goes through the points 1, 1, 2, 2, 3, 3, 4, 4. It's the line x equals y. If we were looking at x and y axes, that's 45 degrees. And we also have a way to determine the length of this radius. We know the horizontal and vertical sides of the right triangle. The real part is the horizontal 4. The imaginary part also is 4. And we can use Pythagorean theorem. Square root of x squared plus y squared is an expression that we're going to be using a lot going forward. So I'm getting used to thinking of just square the horizontal, square the vertical, add them up inside of a square root. Square root of 16 plus 16, a couple of steps here, added up equals 32. Let's simplify this radical. I know 32 is 16 times 2, so we have 4 times radical 2. There is the length of the radius. So we can describe the complex number 4 plus 4i by using the angle and radius. In general, we could say a complex number in the form a plus bi, knowing that we could plot that point where a, the real part, is the horizontal, and b, the imaginary part, is the vertical. Here's the horizontal and the vertical. Horizontal is r times cosine theta. We know that from trigonometry. It's the horizontal part on the real axis. And r times sine theta will be this vertical component, and that is vertically on the imaginary axis. Since both of these terms use the same value r, we can factor that out, and we'll commonly see in trigonometric form r times this quantity, cosine theta plus I sine theta. And that theta, it's going to be just this angle of rotation, so we'll always be seeing the same angle measure in each of those thetas. A shorthand way we could write it would be r times cis theta, or kiss theta, and that stands for cosine theta plus I sine theta. I like to use this abbreviation, but understand that this is really showing us what math is involved. Multiplying the radius times cosine is our horizontal. Multiplying the radius times sine theta is the vertical, and we're using real part on horizontal axis, imaginary part on the vertical axis. This number, 4 plus 4i, we could write it in trig notation as 4 radical 2 kiss 45 degrees. But understand that this means 4 radical 2 times cosine 45 degrees is the horizontal, the real part. 4 radical 2 times sine 45 degrees is the vertical part, the coefficient of I. Writing it with the r factored out front, 4 radical 2 times cosine 45 degrees plus I sine 45 degrees. And understand, this is just another representation of the complex number 4 plus 4i. They are totally equivalent numbers, just written using different notation.